Alright, General Electric, Section 10 Series 7, 7 Series, instructions. Engine support system, introduction, fuel oil system, description, fuel tank, electrical, emergency fuel cutoff system, filling, drainage, fuel, oil, filling, draining, lubricating oil system, description, oil flow outside of the engine, oil flow inside the engine, lubricating oil pressure, filling and draining, changing oil, filling, draining, changing oil, cooling water system, description, system operation, fluid, amplifier, filling and draining, equipment and air system, and air engine air system. Introduction. The section covers the various engine with the support systems on board a locomotive. The intent of the section is to provide the understanding of how the individual systems of equipment contribute to the function of each of the pertinent systems. This will aid the maintenance personnel in diagnostic malfunctions, determining the correct procedure to be followed to resolve the problem, and also intended to be with the conjunction with Section 4 for diesel engine instruction to diagnose the problems when they occur. It should be noted that the variations in the system exist between the different models of locomotive between the railroad customer, and because of the complexity of the system, liberties have been taken of the method presentation. Some engine support systems are presented with a diagram, some of them line drawings. In all cases, the diagram and drawings are intended general guidance of the personnel. Fuel oil system. Description. The engine fuel supply is contained in a fuel tank located below the locomotive platform. Fuel is drawn from the tank with electrical driven fuel booster pump is circulated through the system. Figure 10.1. The fuel system consists of the following components listed in order and fuel flow from the fuel tank through the system. Fuel tank, fuel heater, optional, single element, fuel strainer, fuel booster pump, relief valve, primary filter, engine fuel header, injection equipment, regulating valve, fuel drain headers. Suction side of the system is between the tank and the fuel booster pump. The fuel is drawn through the fuel heater, optional through a single element fuel strainer before reaching the pump. Alright, this is a diesel engine fuel oil system. The black is the suction, the gridded is the atmospheric, and then the dash is measured, pressurized. From the bottom line, you have the dial gauge optional, fuel level gauge both sides, and vent tube, and then the fuel level gauge both sides, and a plain drain plug both sides, showing the cotter pin, drain hole, bushing, copper, asbestos, gasket, brass, bolt. Then from the top you have your fuel headers. Then on the side you have your fuel drain header, both sides, engine returns the oil for injection pump of the nozzle. Pressurized relief valve, fuel filter drain valve, fuel transfer pump, and fuel heater when used. 2 cab gauge pressure regulating valve, drainer header. The pressure side of the system is located between the booster pump and the pressure regulating valve, which discharges excess fuel back to the tank, and the fuel discharge of the booster pump flows in the single element fuel filter. The relief valve is also connected to the pump discharge to protect the booster pump from overloads caused by flow of the restriction pressure side of the system. Fuel is then conducted through a pipe to the engine fuel header. Individual flexible hoses connected to the engine injection pump inlet. Fittings make up the engine fuel header. With the fuel header levitates for the supply of the first fuel over the injection pump at the right bank, then crosses over by the turbocharger supply of the injection pump at the left bank. Excess fuel is returned to the tank and regulated with the valve with which to adjust the maintained pressure in the engine fuel header. Two fuel drain headers on each side of the engine frame collect the fuel leaking from the injectors and the high pressure pump directed back to the fuel tank. The fuel tank units equipped with the signal fuel supply tank centrally located below the platform. The tank is equipped with 2 filling openings, one on each side of the tank of the fuel level. The side glasses, one near each of the top filling opening, are standard equipment on the tank. The fuel level, the dial gauges may be applied with the tank. The optional equipment at the bottom of the tank that serves as the sump and is equipped with a drain plug at each end, 1 vent pipe vents the tank of the atmosphere. Electrical emergency fuel cutoff system. Electrically operated with the emergency fuel cutoff system is arranged with the 3 emergency trip switches, one located on the right side of the floor with the number 1 lifting lug on the left side of just above the number 1 end of the fuel tank. On the operator's cabin, momentarily depressing any one of these switches will cause the fuel booster pump to stop, stopping the flow of the fuel through the engine. At the same time, the signal of the governor stop of the engine once the trip system is restored to the normal, depressing the reset button with the operator's cab upon the reset. Starting the engine, the system is reset automatically. Filling and draining fuel oil. The fuel oil recommended for the engine is distilled fuel that should conform with the American Society of Testing Materials specification D975 or number 2D for the extreme low temperature for the engine operating with a high altitudes, and numbered ID fuel with a minimum cetane value of 45 may be used. Filling Fuel filling may be done from either side with the locomotive applying with the fuel hose. Filling open. The fuel fittings may differ depending on the customer preference. Preserve the upright side of the gauge periodically during the filling will determine when the tank is full. The fuel supply may be determined at any time with observing the upper and lower side glasses on the fuel dial gauge if used, indicating fuel level draining. The fuel tank should be periodically drained with accumulated water condensate. The use of the drain plugs at each end of the tank sub. The plugs are made with a straight thread screw which contain with a drilled passage, and it has an internal stop to limit the number of the turns that can be opened. And the excessive amount of the water is found in the fuel tank. Check the engine fuel filter, fuel heater. If used, the system fuel supply should be made immediately. Also check the possibility of leakage from a cylinder may be getting with the tank through a fuel return header. If the water is permitted to enter the fuel system, it can cause extensive damage to the system parts. Large quantities of the fuel may be drained quickly from the tank. Removing the drain plug from each end of the tank sump. The sump ends for the covers may be removed to gain access to the tank while internal cleaning becomes necessary. Lubricating oil system. Description: the diesel engine lubricating oil system figure 10.2 provides the pressure lubrication of the bearings of the engine and carries out away heat with the produced with the friction of the combustion. Lubricating oil system is also full flow type, and that all of the oil used must circulate with a low oil filter. Therefore, there's no oil filter. If there is no oil filter bypass valve, then the provisions of any of the kind would permit unfiltered oil to circulate through the system should the filter become obstructed. The system is used to prevent unfiltered oil with the harmful foreign materials in it may contain the contaminating engine that contains low oil pressure device provided the control governor the device sample exists in the oil pressure. Should the pressure drop to the submittal normal will cause the engine speed to load in the reduced value. If the pressure drops to dangerously low value, approximately 4 psi, the device will cause the engine shutdown. Lubricating oil system consists of the following components in their order. The oil flow figure 10.2 shows the engine crankcase, pump, relief valve, cooler, filter, engine supply system. Alright, 1 is your crankcase suction strainer, 2 is the main oil pump, 3 is the relief valve, 4 is the cooler, 5 is the filter, 6 is the filter vent, 7 is the casting header, 8 is the cab pressure gauge, 9 is the gauge snubber, 10 is the control governor, 11 oil line control governor, 12 governor drive assembly, 13 oil line to the governor drive, 14 overspeed governor, 15 overspeed derated linker, 16 oil supply line overspeed governor, 17 oil line governor to link, 18 oil drain line overspeed governor to the crankcase, 19 lube oil temperature switch of the end of the train, 20 hot oil temperature switch hot head end of the train, turbocharger 21, 22 oil supply line and turbocharger 23 supply discharge from pipe from the turbocharger section, 24 suction for ejector pump if used, 25 oil from the header if used, 26 suction oil discharge pipe if used, 27 oil fill assembly, 28 oil level dipstick, 29 fill drip plan. An oil pan is bolted with the main frame that's included at the bottom of the crankcase and holds the oil supply with the oil filling pump, oil filling opening to seal with the expandable plug. A dipstick is used to measure the crankcase oil level of the engine idle. Oil flow outside of the engine. Oil discharge from the pump of this pipe with the lube oil closed cooler with the relief valve of the protect the system against the excessive pressure of the oil flow through the cooler, then returns to the oil filter. Water flowing down through the tubes inside of the cooler remove the heat from the oil with the oil discharge from the filter pipe the engine forward free of the and cover. Alright, oil flow inside of the engine. The main engine supply header of the branch and the branch passages within the main frame conduct all the main bearings with the 4 camshaft gear bearings that only enter for the crankshaft with the main bearings flowing for the angularly drilled passage shaft of the crank pin bearings. The oil passes for the crank pin up through the bolt of the connection rods to the lubricating piston pin with the oil then passes for the piston crowns and shake it around with the chamber until under the piston crown, thereby cooling the oil piston head, then flows through the drain holes back to the crankcase. The oil enters for the crankshaft bearings conduct lengthwise there through the drilled camshaft holes, drilled radial and shaft supply oil to each of the other shaft bearings. The camshaft bearings contain an angular groove connecting with the drilled passage of the engine mainframe with the oil flow through the passage to the fuel with the fuel push to the rod across head. Or the engine flows upward through the valve push rod to the supply of lubricating to the valve that operates part of the top of the cylinder, and oil return through the valve push rod of the cavity to lubricate the cams and cam rollers then to the crankcase. The forward end for the cover of the bearing and the idler gear with the brush is lubricated through the passage for the oil header with the angular groove of the round of the covered bearing, and another drilled passage connects angular bearing groove to the drilled passages in the idler gear shaft of the auxiliary drive gear located with the crankshaft next to the vibration damper. Lubrication is internally by oil flow through the passage within the shaft through the gear hub. Oil then from these bearings return to the gravity to the crankcase. Turbocharger bearings receiving lubrication through the external line of the flange, lubricated with the oil header as the forward end of the cover from the turbocharger. The oil is returned to the crankcase through a pipe that is also flange connected to the cover. Lubricating oil pump is to the governor drive assembly through a pump with the flange connected with the engine oil header with generated end. The oil from the governor drive is returned to the crankcase internally. The oil supply of the overspeed governor is maintained with a small reserve in the governor drive gear cave. The reserve is kept filled with the oil drill passage in the gear cave. The camshaft gears are splashed lubricated through an orifice pipe with the engine oil header. The bearings, driver gears, the oil water pump that are lubricated with running partially submerged in the lube oil contained with the forward end of the cover reserve. Lubricating oil pressure. Oil pressure must be maintained at all times during the engine operation. Sufficient oil pressure will cover the extensive damage to the bearings, pistons, cylinders, other moving parts of the engine. The lube oil pressure device will stop the engine and turn on a yellow indicating light in the operator's cab if the conditions insufficient oil pressure exists. During the engine starting, the time delay built into the low oil pressure shutdown allows the time for the engine's oil pressure to build up. If the pressure fails to build up within the time allowed, the oil pressure device will trip and prevent the engine from starting. Alright, filling and draining and changing the oil. Filling. The surface of the lubricating oil system proceeds. The valves check if the drain valve A, B, and C as are closed. Figure 10.2. Fill the crankcase through the oil fill pipe through the crankcase inspection opening with the correct quantity of the new lubricating oil. The oil must conform with the required specification. Fill the crankcase to the full level of the mark on the dipstick. 3. When the engine idling, oil level must be between full and low marks on the dipstick. Regardless of the time and the mileage of the lube oil should be changed whenever the contamination of the water or fuel oil reaches closely approach of the contaminating limit. Given any of the lubrication servicing instructions should also be changed when the condition with the fine metal particles such as contamination could result with the scoring of the piston rings, liners, crossheaders, or guides, lube failure to gear or bearings, any other similar worn failing parts. Drainage. The lubricating oil system is drained by using 3 valves which are located and identified as valve A, valve B, valve C in figure 10.2. The following list is identified with the valve combination of the valves which must be open to drain the various portions of the system. Alright, valve A, the crankcase drain valve is open to drain the main oil supply for the engine crankcase. Valve B, the end covered drain valve drains the oil filter with the oil cooler and on board. Valve C, the filter drain back valve drains the oil filter, oil cooler back into the crankcase. With valves both B and C both open, the oil filter and oil cooler in front end of the drain overboard. Changing oil. With the engine stopped, remove the pipe with the gap of the drain pipe with the pipe extended below the platform over the fuel tank on the right side of the engine. 2. The range of the barrel with the drain hosing to catch the used oil. 3. Open the crankcase drain valve A and then cover the drain with cover drain valve B and filter drain back valve C. Remove the vent plug with the filter cover when the old coil is completely drained. Close valve A, B, and C. Place the vent plug and the filter with the cover to reapply with the cap of the drain plug. Cooling water system. Description: the locomotive cooling water system figure 4, figure 10.3, 10.4 maintains essentially consistent engine operating temperatures throughout the loading range with a wide variation in ambient temperature. Figure 10.3 shows a simplified version of figure 10.4. Consider the heat generated as a result of the fuel with the combustion diesel engine friction caused by moving parts of the engine, air compressor compression of the intake air by the turbocharger compression of the air by the air compressor. Unless the heat is removed the same the rate is generated, heat would soon destroy the gaskets and seals and hoses, etc., would ultimately destroy the engine air compressor. Most generated heat transferred from the metal with the masses directly to the coolant. About 20% of the engine heat is transferred to the lube oil, then through lube oil cooler to the coolant heating, then transferred from the coolant to the atmosphere through the radiator sections. When equipped with the warm coolant, heavy heat as the fuel oil through with the fuel oil heater. A pressurized dry radiator type system is employed with the rate of the transfer of the heat from the coolant to the atmosphere depending on the atmospheric temperature and the pressure, and the heat rejection from the engine is controlled by fluid amplifier flow control valve in the system. The principal components of the system are water storage tank 1, 2 lubricating oil pump, cooler 3 water pump, 4 water inlet headers, 5 water outlet headers, 6 cylinders, 7 intercoolers, 8 turbochargers, 9 fluid amplifier flow control valve, figure 10 radiator sections, 11 RAM air compressor, figure 12 fuel oil filter optional, and 13 valve switches interconnecting piping. Alright, we're going to back out of this. This is your water flow diagram view. Alright, you have your radiator outlet pipe on the B side of the locomotive and the A side of the locomotive, from radiators going from top left to bottom right. 1, 2, 3, 4, 5, 6. It shows the legend main flow of the oil with the dotted arrows. The path is main flow of coolant control fluid. Light arrows. Diesel engine water discharge header number 2, proportional diverting valve and pilot valve, and thermostatic pilot valve into the number 1 proportional diverting valve, pilot valve, through the fluid amplifying flow control valve to the tank. Thermostatic pilot valve, and into the radiators out through the radiator outlet pipe. Alright, 1 is your water storage tank, 2 parts intercooler, 2 is the tank screen access door, 3 is the lube oil cooler, 4 is the cooler water screen access cover, 5 is the water pump, 6 is the water pump drain plug, 7 is the forward and covers, 8 is turbocharger, 9 is interlocking left side, 10 is the interlocking right side, 11 the water inlet header right side, 12 engine cylinders, 13 water outlet header, 14 water discharge header, 15 flexible connections, a rubber boot, 16 fluid amplifier flowing control valve, 17 the hot water temperature switch, 18 radiator inlet pipe and point over the radiator carb structure, 19 radiator, 20 radiators outlet pipes, 21 radiator vent tubes, 22 air compressor, 23 air low pressure device inlet for the control governor, 24 hose, 25 lube oil heater and if used, 26 lube oil, fuel oil connections and heater if used, 27 water fuel fill pipe, 28 water fill valve, 29 water tank fill cap, 30 water tank vent valve, 31 water tank level gauges, 32 water tank temperature gauges, 33 vent drain pipe, 34 I'll increase the volume. 34 orifice block, 35 pilot valve orifice inspection rings, plugs, 36 automatic drain temperature switch, 37 automatic drain magnet valve if used, 38 automatic drain reset switch if used, 39 thermostatic pilot valve, 40 water pump telltale hole. Alright, system operation. The cooling water system is a pressurized dry radiator type system. The system, when in operation, must be tight and free of all leak, though, so the pressure can be maintained with the dry radiator system. Is one half of the no coolant in the radiator section where the engine is shut down when the coolant temperature is in lower range for the operation, with the coolant temperature go to the medium, the higher range for the operation. Coolant is diverted into the radiator section for the cool down. Feature is mandatory with the ambient temperature for the sub-freezing, since the radiator sections are outside of the zone of the heat generated for the diesel engine. Water leaving the storage tank of the drum downward through the vertical tube with lubricating oil cooler and his pipe at the suction side of the engine driving central figure water pump. The water discharge from the pump enters the lateral passage into the front end of the cover of the engine, where it is distributed to the water inlet header of the turbocharger for the inlet coolers. The water inlet headers, one along each side of the engine, were distributing cooling water to the cylinder. These headers compromised with the suction, which are individually removable. Each section is both of the cylinder and an adjacent section of the compression pipe of the couplings. Each cylinder contains a liner with whose outer surface is machined to form two annular water bands with the water frame of the water inlet headers coming to the jack of the wall. Distributed around the liner with the lower waste water band is then passed through the 1/8 inch angular space formed by the distribution dam with the outside of the diameter of the liner and the inside diameter of the jacket into the upper water with the band, from the upper water band and continue with the head through the large number of the holes drilled in the upper inner liner wall. The engine intercoolers, which remove the heat from the combustion air, but the air is constructed with the fabricated steel with the cause the case enclosed the fan and tube type filler radiator core, cooling water from the forward end of the cover, the inch of the bottom of each for the intercooler passes vertically 3 times through the core and then discharge for the top of the cooler. Water flow through the intercooler is limited to the orifice for the cooler discharge opening. Turbocharger located in the forward end of the engine receives the cooling water with the 2 openings within the top surface of the forward end of the cover. These openings are aligned with the openings within the base of the turbocharger bracket with the turbocharger feet directly making the connection with the sealed O-rings. Water discharge for the turbocharger openings near the top of the exhaust gas inlet side. Openings are connected with the discharge pipe from the left intercooler. The water outlet header is certainly located lengthwise over the engine with a discharge opening connected to the junction box at the top of the right intercooler. The branch pipe is welded to the header of the tank with the individual cylinders, compression pipe fitting with the water flowing from the intercooler, turbocharged water discharge header combined with the junction box is conducted with the fluid amplifier flow control valve. Fluid amplifier flow control valve regulates the temperature of the system, riding with the water flow for the engine valve directly with the water storage tank with a minimum engine cooling is required. 2 to the left bank radiator sections when partial cooling is required, and 3 to the all radiator sections when the full engine cooling is required. Water cooled in the radiators then to return to the storage tank for the minimum cooling with the flow water with the radiators cut off by the flow control valve, and the water left in the radiator sections and piping is quickly drained to the storage tank by gravity flow. Fluid amplifier. Hot coolant lead for the diesel engine figure 10.3 with the enter for the inlet port with the fluid amplifier flow control valve inside of the valve housing. Coolant drive it into the 3 paths. A small quantity called the flow control fluid passes into the thermostatic pilot valve of the main flow, with the coolant divides into 2 parallel systems. A small portion of the coolant with the control fluid sends in the thermostat with the thermostatic pilot valve, with the thermostatic pilot valve control of the fluid, control of the fluid, which in turn through the transverse of the jet and the fluid action diverts the main flow with the coolant with the tank and or radiator with the control large for the main flow with the coolant, small control flow with the application of the small control flows given the term fluid amplifier. The path of the 2 parallel low fuel low system depend on the coolant temperature, thermostatic pilot valve, and are through the inboard number 1 proportional diverting valve of the pilot valve, then to the tank, and then the left bank radiator. 2. Through the outboard number 2 proportional diverting valve and the pilot valve, then to the tank and or right bank radiator. Filling and draining. Filling. Detailed instructions of the filling of the water tank are mounted on the water tank. Draining. To completely drain the system, open the valve A and remove the plug remove the pump drain plug figure 10.4 item 6. Alright, your equipment and engine air system. Equipment air system. Air figure 10.5, the engine for the equipment blower compartment forward with the engine compartment, the 6-axle locomotive and the V-screen with the bull side with the locomotive with the lower forces over the air into the main air duct, which extends almost the full length of the locomotive is formed of the 2 main sills at the top of the platform deck at the bottom platform plates that join at the bottom of the portion of the 2 main sills. Note, the 4-axle locomotive has a blower in the rear of the locomotive. The pressurized air flows both forward and into the rear of the blower inside of the main air duct. The air flows through the plastic air containers located in the duct, then through the traction motors alternated with the traction gear, generator, auxiliary generators, control compartment, rectifier panels, operating cab, and to the extended range dynamic braking compartment if used. Discharge air from the alternator pressurize the engine cab, and thereby excludes the outside of the dirty air for the area from this area. Some of the pressurized engine cab air and escaping with the outside of the exhaust stack helps direct the exhaust gases up and away from the locomotive. The balance of the engine cab and the air passes through the air compressor to the drive shaft tunnel with the air compressor intake filters. Each air cleaner is compromised with a 54 individual tube. Each tube acts as a miniature cylindrical dirt separator of the air, incoming air into the veins of the tube, causing the air to swirl. Dirt particles being heavy to go out to the outside of the eventually leave far and out of the tube. The clean air swirling in the central portion of the discharge of the cleaner. Bleed air carries the dirt out of the cleaner. Opening at the bottom of each panel with the permit with the separated dirt with the bleed of the air to escape. They continue with the discharge of the locomotive through the outlets beneath the underframe. Test results show that most of the dirt and particles of the 8 microns or larger are removed from this cleaner. The micron is 1/millionth of a meter with approximately 1/25,000th of an inch. Engine air system. The engine air cleaner system is located between the engine cab, the radiator cab, the ambient air engine for the locomotive through the screen air inlet with containing three plastic air cleaners. Located just above the platform, walk away on each side of the locomotive. The cleaner air is collected with the cleaner air plenum delivered up through the secondary paper air filters into the intake of the turbocharger. Dirt bleed and discharge without a hole on the end of each of the primary cleaner into the air duct. The bleed air then discharges out of the stack utilizing the exhaust stack aspirator check valve with the prevents engine for the exhaust gases entering the clean air system through the bleed air duct. Two safety and protective devices ensure the adequate supply of the air delivered to the engine combustion. These devices are a service indicator, which indicates whether the air cleaner system needs servicing, and two, a pressure switch return for the engine idle that actuates the train line arm. It illuminates the engine air filter light on the engine control panel that prevents diesel engine operation with the plugged air filters. Alright, figure 10.5, equipment engine air system 6-axle locomotive. Alright, your dash line at an angle, atmospheric angle. The clean air is clean air, dirty bleed air is black. Alright, the operator for the cab heater to control equipment to the traction motor to the incoming air, the equipment blower to the alternator rectifiers and the air cleaning element, the main air duct, the exhaust gases, the gas aspirator to the diesel engine, the rear traction motors. Check valve primary filter. The check valve of the primary filter outside air screen, secondary filter turbo to exhaust stack of the gas aspirators, and that completes the reading of the engine support system, section 10 of the GE Series manual.